Okay, so in this question, they're asking us to consider sort of two sectors, okay, and there's one sector sort of contained within the bigger sector, okay, so you can see that here. So we've got the sector they start off with ADC, okay, so ADC, that's the large sector, okay. Remember, sector's like a slice of pizza, and it's got a center, of course, at A, right? And AEB is the sector then also with center A, okay, so AEB there, so smaller sector sort of contained within this larger sector. And it says then calculate the perimeter of the shape BCDE, so as if they cut this sector out, okay, and you're left with then this sort of shape here, okay, so ignore those broken lines there, you've got then this shape here, and they want the perimeter of it. Now, the perimeter of it, of course, we know this side here is 6.8, okay, which of course then it makes sense then to realize, well, this side is also 6.8, okay, right? We know that this arc here is 6.4, so all we need is this arc here, DC, okay, that's all we're missing. Right, now in order to get that arc there, DC, we need to do a little bit of work, and of course when there's an arc, it's just obviously a fraction of the circumference, isn't it? You need to think about it like that, it's a fraction of the circumference, and usually the angle, of course, is going to help, isn't it, to know what fraction it is. So I don't actually know what that angle is, so maybe I'll call that angle X, okay. And if we maybe can work out that angle X, then it'll help me then to work out my arc length here, DC. The good thing is, right, if I consider the smaller sector, right, AEB, so if we focus on AEB sector for the moment, we do know the arc, don't we? We know the arc length there, so we could say, like, arc length of the smaller sector, AEB, the arc length is 6.4 centimeters. All right. We also know its radius. We know the radius of this smaller sector here is 7.5. Okay, so because they are talking about the arc length, what I usually do then is, right, if I want to work out the angle, I consider the whole circle, okay, because it is part of a whole circle, and I think about working out the circumference of it, okay? And I'm going to do circumference because I know the arc. It's all about the arc, isn't it? It's not about area, okay? There's nothing about area in this question. We're only interested in the arcs. So if we want to consider the arc, I would first of all consider the full circumference of that circle, okay? And the good thing is I can work out the circumference of this circle, okay? So the circumference is equal to, of course, pi times diameter, isn't it? That's the formula for it. And pi will be 3.14. Of course, the diameter, we need to be careful. It's not 7.5, isn't it? Because that's the radius. It's going to be double that. So it'll be 15. So if I work that out, 3.14 times 15, and I get 47.1 centimeters. Okay? So that is the circumference. And then I need to appreciate that the arc here, arc EB, is just a fraction, isn't it, of the circumference, okay, a fraction. And in terms of what fraction it is, well, the fraction will be the angle here out of the total of 360, yeah? So I can say, look, my angle, which is angle X, okay, that's just a fraction of this sector, don't forget, this small sector is a fraction of the whole circle, and the fraction will be the angle X out of the whole circle, which is 360. And if I times that by the circumference, I will get my arc length, which is 6.4. So it's important to see that, see what's going on there. Fact is, if this is the circumference of the circle, okay, all the way around, okay, well, the arc length, EB, which is 6.4, basically is going to be a fraction of that circumference, isn't it? It's going to be a fraction of 47.1, and that fraction is whatever x is out of 360. Now I've got an equation and I can work out what x is. And it's quite simple. What I do is I'm dividing by 360, so I'll take that 360 up, okay, and times. Yeah, that's what you do, because you divide by 360, take it up. And because you times in by 47.1, I'll take that down and divide. And straight away then I'll get my x. So I use my calculator. and I get 48.9. Okay, 48.9. Maybe we'll go for two decimal places. 48.92. Okay, centimeters. No, degrees, isn't it? Because we're talking about the angle there. Okay, so now I know this angle is 48.92 degrees. Now I know the angle, I can work out now my arc length, can't I? Okay, that's the good thing about it. I can work out the arc length because, of course, I know this larger sector now, which is ADC. Okay, I know the angle to be 48.92 degrees, and I know the radius. Well, the radius is these two combined, isn't it? That'll be the whole radius. If I add them together, I get 14.3. So then, to get the arc length, I've got to do the fraction, which will be 48.92 of the full circle, which is 360, and I need to times that then by the circumference. Now, I haven't worked out the circumference of that large circle, okay? But if you think about it, that arc there, okay, it's important. If you think about it, that arc there will be a fraction of the full circumference, and the fraction will be 48.92 divided by 360 of the full circumference. And the full circumference is just pi times diameter, isn't it? Pi times diameter. Okay, so that'll be 48.92 over 360 times 3.14 times then the diameter, which will be double that, which will be 28.6. So we'll work that out. And we get out to be 12.2 centimeters. So then, to get the whole, if I know that's 12.2, okay, I'll write it up here so it's clear for you. To get the whole then perimeter, okay, you just need to add these together, right? So the perimeter will be 6.8 plus 6.8 plus the 6.4, okay? So those three sides there, and then the 12.2. So if I work that out, I get that out to be 32.2 centimeters, okay?